Also, it's a pleasure to chair the session 7 on societal and policy implications of AI. The first talk is going to be on the backfiring effect of weak AI safety regulation by Ben Laufer. We have 4 talks in the session, 60-minute session, so 15-minute each talk. I'm going to give maybe a 5-minute and 2-minute warning so that you know when you're within 15 minutes.
Hi, everybody. Okay, so it's great to be here. I think this is my third emo, so that's fun. This is the backfiring effect of weak AI safety regulation and its joint work with John Kleinberg at Cornell and Hoda Heidari at CMU. And before I start, I'll just quickly say I'm on the job market. I'm interested in research on AI ecosystems, so the incentives and actors and sort of constellation of decisions surrounding the development of AI technologies, and especially normative levers for fair and trustworthy algorithmic decisions. Okay, so I just want to start with a very broad sort of introduction here, which is that there's a sense right now that the potential uses of large language models and related technologies are vast. But within a domain, it seems that some uses make sense and others just don't seem to make sense. And so when we're thinking about safety, societal benefit, or even just economic viability, this will depend on the context and the specific domain where a use is being proposed. And this general idea that there are a variety of contexts where a technology might get introduced relates to a concept known as general purpose technology, which comes to us from growth economics. And there's recent work that connects this concept to AI and large language models. This is the smallest text slide, so I'm hoping to make the text as visible as possible for this room. Okay, so, and just to drive this point a little bit further, there have been various proposals over time that these major big tech companies, including OpenAI, will introduce marketplaces where AI will be available to people, not just in the general form, but in particular applications. So in January 2024, Sam Altman announced that there would be a GPT store. And he said, revenue sharing is important to us. We're going to pay people who build the most useful and most used GPTs a portion of our revenue. This hasn't happened yet. And just a few weeks ago, OpenAI announced a new but very similar sounding idea, which is apps you can chat with. And now there's a sort of software development kit for developers to create apps that pop up as you're chatting with ChatGPT. But still the revenue sharing is TBD. Okay. Okay, there's some formatting issues here, but broadly, this led to a model which we developed a few years ago called fine-tuning games, where we try to model the different interests of a sort of multi-purpose technology producer and one or multiple downstream adapters of that technology. And the key ingredients are that a generalist develops capabilities that can be used across domains, and then one or more domain specialists can adapt it to their domains. These have different competencies, and they might engage in bargaining over sort of like a linear contract to decide how they share revenue. In ongoing directions, of course, this basic model is sort of stylistic in some ways and imagines there's a single multi-purpose technology and one or multiple domain specialists, but the structures of these different entities contributing to the development of the technology can be much more complex. So in recent work, we've scraped models on Hugging Face, and we can see whether one model fine-tunes from another model. And we see these sprawling graphs of fine-tuning relationships that are more complicated than this model might suggest. And so I see this as an exciting area for future work. But what I want to talk to you about today is regulation and responsibility. So there have been many sort of splashy headlines about when sort of these systems that are infused with, machine learning or AI technologies, when these cause harms, who should be responsible? And this relates to the broader idea that these sort of complex socio-technical systems exhibit so-called many hands problem. Okay, so today what I want to talk about is the question of regulating these complicated systems. So here I've put up 3 example AI regulation bills. 2 of them have passed and will take effect in the coming years. 1 of them did not pass, the California one. But importantly, all 3 of these, the Colorado AI Act, the EU AI Act, and California's SB 1047, differentiate between these different actors. So there's a developer who develops some multi-use technology, and then there's a deployer of some system. And the requirements that regulation attaches to one of these entities depends on which entity they are. And so the question that we want to ask is, who should AI safety regulation target? Should it be targeted upstream, downstream, at both, or at neither? And again, we have a little bit of formatting problems, but the point is we are attaching another step in our original fine-tuning games model where we have a regulator who's deciding who to target along this chain, whether to target requirements upstream at the generalist or downstream at the domain specialist. And so here is the most mathy slide. So this is the model. The model is composed of a series of steps. The generalist first invests in the technology, and then the domain specialist takes a turn at investing. The technology is described by 2 attributes, which we're calling performance and safety. Performance is we call alpha, and safety we call beta. So these 2 values start at 0. The generalist brings the performance and safety to some alpha naught and beta naught. And then the domain specialist can sort of contribute some additional investment to alpha 1 and beta 1. Revenue then comes in as a function of these final values. So revenue is a function of alpha 1 and beta 1, and both players have to spend some cost in order to do their investment. And so because revenue comes in at the end, the question is, how do the players distribute this revenue? And so we allow a linear contract where the generalist can get some portion delta and the domain specialist can get the rest. And so the utilities are simply the player's revenue shares minus the cost of investment. And for a running example here, we're going to use the case of quadratic cost functions. So this is a family of functions that's somewhat restrictive, especially with one attribute. But with multiple attributes, quadratic functions actually start getting pretty flexible and complicated to work with. And in particular, we're able to describe 2 different scenarios, one where the 2 attributes are complementary, meaning that investing in one makes investing in the other cheaper, and intention, meaning investing in one makes investing in the other more expensive. Okay, so now I'm going to show a single instance of this game. So we imagine that there are 3 specialists in this instance, and each has different cost functions that lead to a different interest in pulling the technology in this sort of like 2 attribute space. So imagine that the 3 specialists are something like a big hospital system wanting to invest in a medical note summarization task, an airline investing in customer service bot, and a journalism a big newspaper wanting to introduce some tool in their newsroom. And so each has different interests in some balance between these 2 attributes, performance and safety. And what I'm showing here is the game under no regulation. So the generalist provider brings the technology to some combination of these attributes, something like 0.75 of each. And then each of the 3 domain specialists will then move the technology somewhat further. And now we can ask, okay, imagine that a regulator sets a threshold that's targeted at the domain specialists, and the threshold is at this value of 1. And we call this weak regulation because the minimum requirement on safety is lower than all of the players already reach without any regulation. So you might imagine in this scenario that this would not affect the game because the players are already compliant. But what we see is that actually the players change their strategy pretty radically in this stylized model. And now the players are minimally meeting the regulation which means that the safety achieved is lower than it was under no regulation. And to give a sense of why this is, it has to do with the order of play. So because the regulation is targeted at the specialists, the generalist says, okay, now I know that I can drop my investment in safety because the specialists have to meet this minimum regulatory floor. So this generalist can sort of push these requirements onto the specialists and do a sort of sneaky cost-cutting strategy. So that was a single instance, but we can provide a general characterization over all quadratic cost games. And this characterization is quite general. So we say a fine-tuning game exhibits backfiring if and only if there exists safety regulations for which the game yields lower safety than it would under no regulation. And we find that in all quadratic cost games, as long as the players are investing some non-zero amount in both attributes, we can produce backfiring exists in all such games. Okay, now we return to our single instance and we imagine a slightly different regulation. Here, there are two thresholds, one targeted at the generalist and the other targeted at the specialists. And now we find this regulation is binding, meaning it has teeth, it's above where the players would have reached under no regulation. And when we look at the strategies, the regulation is doing what we would want it to do. The players are minimally complying if they were below the regulation in the sort of anarchy or no regulation scenario. And the players that already cleared it are actually ending up at a higher safety level as well. But the real head scratcher here is that when we calculate the players' utilities in this model, we find that they're actually better off than they were in the case of no regulation. So the utilities are higher. And this is a real head scratcher because the question is, if all of these attributes were feasible when there was no regulation, why wouldn't the players just choose these strategies to begin with? Before I answer that head scratcher, I'm going to leave you in suspense and give the general characterization here, which is a fine-tuning game exhibits mutualism if and only if there are some regulatory thresholds that Pareto improve the player's utilities compared to the absence of regulation. And if we consider the cost of all quadratic games, again, we can come up with a general characterization of when mutualism occurs. I'm not going to get into the specifics, but I'm happy to talk about it offline. And the plot on the right here is the space of regulation. So on one axis is all thresholds directed at one player, and on the other axis is all thresholds we could direct at the other player. And we see these regions where either backfiring or mutualism occurs. And so now I'm going to answer this head scratcher. Why can the player's utilities improve? And the way I think about this is a protocol design perspective. So when I introduced the game, I mentioned that there was a linear revenue sharing parameter. This allows the players to split revenue in a certain way, and it affords certain strategies and precludes others. And what we find is that regulation, so some requirements on the players plus a linear contract, is a more expressive form of agreement than the linear contract was alone. And so over the space of all possible linear contracts and regulations, we achieve an expanded sort of utility outlook compared to just the linear contract setting. Okay, so now you can say, this is all great, but what's the point? It's all quite theoretical. And the way I think about this is when we look at these structured incentives, just like the prisoner's dilemma or Braze's paradox gives us some theory to sort of look for in the real world, reasoning at the level of incentives can help us understand the possible impacts of these forward-looking regulations. Okay, I'll leave it there. I hope this gives a taste of the kind of research that I'm interested in, and thank you very much for listening.